Well, good morning, everybody, or good afternoon, wherever you may be. How you doing? John Barber here with Takeo Comfort Solutions, and we are here for another Takeo Tuesday. And today we're going to be talking about heat pump water heaters and how to do domestic hot water recirculation with heat pump water heaters, and whether you should. I mean, these are all open questions. First off, just say thanks for everybody for being here. We do appreciate the gift of your time on this incredibly hot here in New Hampshire anyway, incredibly hot Tuesday morning slash afternoon. It's we're supposed to hit close to 100 today. I mean, which is just unheard of for this part of the world, and I'm feeling it right now. So it's pretty warm. I hope you guys are comfortable where you are. Do me a favor, just so I know that you can hear me. If you can just chime in on where y'all are from, and if this is your first time on a Takeo Tuesday, or if you're a Takeo Tuesday veteran. So if you go to your chat section, your chat question section, and just type it in, and we'll see what's what. Mark Amoroso says it's 100 degrees in Philadelphia today. Hot in Maine, says Thomas. Fort Worth, Texas, says Chad, and it's got to always be hot there. We've got Memphis, we have Chicago checking in, so we're all across this great land. So do appreciate it. So again, folks, please chime in on where you're watching from, and we have a Takeo webinar vet from Connecticut. Excellent. 93 in Vermont. Oh my goodness. Oh my goodness. So it's warm. It's officially warm no matter where you are. You'll also notice that yours truly is flying solo today. Both Jason Cox and Dave Holdorf are out there in the real world doing some teaching today. Dave is in Canada, Ontario, doing some training outside of Toronto, while Jason is in Utah, preaching good hydronics to all the good folks out there in the Rocky Mountains. So we're really excited. Or those are the Rocky Mountains up in Utah. They extend. So yeah, I got that right. We got so it's all by my lonesome. I'm going to do my best to keep track of your questions as well as keep the discussion on track. Do me a favor, when you do have a question on anything that pops up in this session, just type it on in. I'll be keeping an eye on things. So if I'm looking, you see me looking over here, I'm checking the question screen, and I will try to answer them as we go. I am not a fan of telling the audience, please hold your questions until the end, because I hope we'll run out of time so I don't have to answer them. But that's not what we're all about. Yeah, we'll stop every few slides and address whatever questions that you may pose and as they pop up. I think it's just a better way to keep it conversational, because listening to me yammer on and inanely for a full hour is probably going to get pretty boring. So anyway, let us get started here, and we're going to talk about domestic hot water recirculation for heat pump water heaters. Now, let's see, Peter up in Vermont has his heat pump water heater working right now. This is a great time to have a heat pump water heater in a garage or something, because it's going to keep the garage somewhat cool. It's going to act like a big old air conditioner. So it's going to do a really nice job. I have a friend who has a heat pump water heater that he puts in his garage. A heat pump water heater in a garage in Vermont's probably not a good idea in the summertime, or in the wintertime rather, but in the summertime, I think it's a pretty good idea. A friend of mine in Florida keeps his water heater, like everybody there, keeps the water heater in the garage, but his heat pump water heater actually keeps his garage so cool and dehumidifies it so well all year long that he actually moved his office to the garage, which he couldn't do before, which I think is kind of interesting. But anyway, let's get started. And again, pose your questions as they pop up to you. I really do appreciate that. All righty. Stop and think. Big old sign like that sort of makes you stop and think, doesn't it? Well, we're going to stop and think a little bit today about heat pump water heaters, or hybrid water heaters as they're called. So let's think about it. In relation to heat pump water heaters and domestic hot water recirculation, we have to take a step back and understand, what does domestic hot water recirculation actually do? We've covered this in sessions before, but I want to pose it to you guys. What's the purpose of domestic hot water recirculation? What does it really do, and why do we want it? Please type in your responses there, because I'm interested in what you folks have to say about this particular topic. What does domestic hot water recirculation actually do? because we have found over the years there are an awful lot of misconceptions, even amongst engineers, who you would think would know all this, but again, there's a little bit there that needs to be understood. So we got Jordan says immediate hot water and increases system hot water volume. I'll go halfway there with you. I'll go halfway with you. Speeds response time for a tap, minimizes frustrating wait times, keeps hot water close to the fixture. Yeah, pretty much. Yeah, I think you guys got it. It speeds up hot water delivery and reduces waiting. That's about it. That's its job. It speeds up hot water delivery and reduces waiting. It doesn't boost pressure. It doesn't boost volume. It simply reduces the amount of time you have to wait for the hot water to show up, whether it's at a shower or at a faucet. And on top of that, it's going to reduce water waste. We're not letting a lot of water run down the drain while we're waiting for the hot water to show up so we can wash our hands or take a shower. Speeds up delivery, reduces waste. Those are the two key elements of domestic hot water recirculation. Does not boost volume. A tempering valve will do that, and it doesn't boost pressure. You need a pressure boosting pump to do that. It just speeds up the hot water delivery. Maybe the best way to look at this, folks, is domestic hot water recirculation keeps that hot water line, primed with hot water, so we don't let that cool down. It's primed with hot water to reduce waste and reduce the weight. Okay, that's its job. That's what it's supposed to do. Okay, does it do anything else? Not really. We got to understand some fundamental truths here. For fundamental truths, it doesn't do anything else that's beneficial. Let me backtrack on that. Does it do anything else? Nothing that is beneficial. Everything else it does can actually be a detriment. All right, if you think about it. Domestic hot water recirculation will make the water heater work harder, whether it's electric, gas, heat pump, doesn't matter. It's going to make the water heater work harder because we're recirculating water through it. So it's going to have a little bit of a fuel consumption hit to it. So it does make the water heater work harder. And it does that no matter how you control the pump. We can minimize that by controlling the pump intelligently. Okay, we can minimize that, but no matter how you control the pump, the water heater's going to work harder. It's going to use a little bit more energy. We don't want to do constant flow. Constant flow is bad on many, many levels. It's in many cases, the simplest way to run a domestic hot water recirculation pump and the cheapest way. You don't need any controls or anything, but it's by far the worst way, both in terms of electrical consumption of the pump, energy consumption at the water heater, and it's pretty much going to ruin your pipes in fairly short order with velocity and temperature and hot chlorinated water. That's a guarantee. That's just going to happen. Timed flow is better, but timed flow also has water running through that water heater when it may not need to, which is going to cause that water heater to work harder, and you're going to be flowing when you don't necessarily need hot water. So there's a little bit of a waste there as well. Those will save water, but constant circulation or even timed flow actually that will cost more. That will cost the consumer more money in terms of making the water heater work harder and in electricity to run the pump. It will cost more money than you would save in reducing the water waste. Okay, that's an interesting element to this that not a lot of people think of. In that instance, with either constant circulation or a timer, domestic hot water recirculation is a convenience item and a water saver item, but it does not save money. You'll spend more running that pump and more with the extra work that the water heater has to do than you will save in wasted water. So you won't be paying for the water, you won't be paying for the drainage to get rid of the water, but that's not going to offset the other costs associated. We can minimize that, and we can actually eliminate that depending upon what type of control strategy we do use. But understand, constant flow or a timer, these are the realities that you're going to be facing. Okay, these are the realities that you're going to be facing. Recirculation does pose a problem for hybrid or heat pump water heaters. Absolutely does, to the point where manufacturers are really kind of exploring how or even whether they would like to do this with their heat pump water heaters, and they have very specific guidelines that you really got to pay attention to, because we can raise, if we don't do domestic hot water recirculation properly with a heat pump water heater, not only will we raise hell with the compressor or the condensing unit, we will we'll turn it into basically a very inefficient electric water heater. You'll be using the electric elements more than you'll be using the heat pump portion. And we kind of defeat the purpose of having this thing. And we might actually also have very inefficient heat, hot water creation and delivery. So we've got to be careful about how we do this, and it needs to be thought through. So again, we can impact the compressor life. As we said, the manufacturers have no real consensus. I wouldn't say they're all over the place, but they do have very specific warnings and guidelines. And we'll cover those guidelines from a couple of the major manufacturers. And it's always something you do want to discuss with your manufacturer before you do anything like this. And we've heard people say, and not water heater manufacturers, but other circulator manufacturers or even water people say, yeah, just run it like you run your recirc line like you always have. It'll be fine. Nothing could be further from the truth. You do need to be cognizant of how you control your recirc pump with a heat pump water heater. So we're going to explore, we're going to look at what some of the manufacturers say, and we're going to explore a couple of options. And really, there is only one good one. There is only one good one that we can look at. So that's, we're going to whittle it down to that. First off, how does a heat pump water heater work? Well, you guys all know how heat pumps work, so we don't have to really go over it again in detail, but this slide actually just does a nice job of explaining it in simple bullet points. First off, heat is drawn in from the air or outside into the heat pump portion up at the top, and we transfer that heat is ultimately transferred to the water storage tank. We use the refrigeration cycle. Warmer blows across the coils with liquid refrigerant. That refrigerant turns into a vapor, pumped through a compressor. The compression heats the vapor up even more, and that is what heats up your water. So again, it's a real rough bullet points, but you get the idea. We use the refrigeration cycle for heating only. There's no cooling involved here, obviously. We use the refrigeration cycle for heating only, but we extract heat from the air where this. That's why it works so great in Florida in a garage. Okay, there you go. Manufacturers have some very specific guidelines. A lot of them have not said anything about this yet. When we were at the AHR trade show in Orlando in February, we discussed with several heat pump water heater manufacturers what their recommendations were for domestic hot water recirculation, and quite frankly, for some of them, it's not something they've really thought about or they have not dived into it yet to kind of come up with some recommendations. So we are in the process of working with some of these folks to kind of figure out what's the best way to proceed for their equipment and to provide that water savings that is so essential in the world today. So here's what some of the manufacturers say. We got this from Rheem, and it's very interesting what Rheem says. They have guidelines for installing a heat pump water heater with, here are the key words, an on-demand recirculation system, on demand. And what they say is a Rheem heat pump water heater can generally be used if the on-demand recirculation system or pump helps provide hot water to a fixture furthest from the unit and does not present continuous pump operation. So right there, they're telling you no continuous circulation. It must be on demand, meaning it has to be user activated, meaning when you're ready to take a shower, you do something, you press a button, whether it's wired or wireless, you press a button to let that pump know that I am about to use hot water. And then that circulator comes on, it evacuates the hot water line of cold or tepid water as quickly as possible, and then shuts off. That's what we would consider an on-demand system. That's not a timer. That's not a smart plug. That's not an aquastat. It is on demand. I'm ready to use hot water. I push a button to turn that pump on. That is that's their guideline. That's their preference. All right. More from Rheem. They do recommend insulating the pipe, which is always a great idea. It's always a great idea. It minimizes electrical usage and extends the water heater's life. So absolutely put some insulation on that pipe. You know, it'll also speed up the hot water delivery no matter what kind of a pump you're using too. So really a good idea to insulate the pipes. And then they give us these bullet points for installation parameters. So again, on-demand recirculation systems should include temperature sensors, or at least a temperature sensor to automatically turn off the circulator. So when the hot water reaches that circulator, it knows to automatically shut off. It's not, again, not on a timer, it's temperature based. It's temperature based. A dedicated return line or a crossover valve can be used. Again, refer to the manufacturer's instructions. So if you have a dedicated return line, great. If you don't, you could still use this setup, again, with an on-demand pump and a crossover valve, using the cold water line as a return. Okay, using the cold water line as the return. Again, you could use the pump under the sink, as we'll show you, and use that temperature sensor within the pump to shut the pump off. Or you could use something like the hot link valve from Taco, which has a thermal sensor disc that immediately shuts off flow once the water gets there, once the hot water gets there. So those are some options. On-demand pump flow rate should not exceed 6 gallons a minute. Recommended flow rate is 3 gallons a minute. Again, that's done to make sure the water gets there quickly. We want to get the water to wherever it's going. We want to get it quickly. And because it's going to automatically shut off, we're a little less worried about some of our guidelines for flow and velocity, because it's not continuous. It's not even for very long, okay? Mixing valve set point, they're talking about a maximum of 120 degrees. They want a minimum return water temperature of about 102. Okay, that's a recommended return water temperature. And then they want you to refer to the pump manufacturer for installation instructions. So those are some installation parameters as presented by Rheem. Okay, the big one here again is flow rate. That's the big one, flow rate. Some more stuff. Failure to follow these instructions might result in less available hot water and lower the unit's performance and efficiency. So again, you say, forget it. I'm going to put it, that's nothing. I'm going to do what I've always done and put it in on just to plug it in and let it run. Okay, you go ahead and do that, but that's not how heat pump water heaters are designed to operate. Okay, that's not their jam, so to speak. So you might have less available hot water, and the unit's not going to be as efficient as it could be or should be, or what the customer was expecting when they had you put the thing in. Again, depending upon conditions associated with a specific application, anticipated energy savings could be significantly impacted, which is another way of saying the same thing. Like this one. Using an uncontrolled recirculation loop may cause the water heater to run excessively. Again, 3 ways of saying the same thing. Basically, they're saying, don't do this, don't do this. Follow their guidelines and do it according to what they say. All right. We had a question. Is there will there be a PDF for this session? Yes, you will receive a email. Everybody here will receive an email at 12 o'clock tomorrow, or noon Eastern time tomorrow, with a link to download your certificate of attendance and a link to the recording so you can watch it again. So all that's going to be coming to you automatically tomorrow. And for those who signed up and did not attend, they don't get the PDF, man. They don't get that certificate, or they don't get this. They don't get the certificate of attendance. That's just the way it goes. Anyway, now here's their piping arrangement, which again is pretty simple and straightforward. Okay, the return line from the furthest fixture, you see the circulator on the return. That return line from that farthest fixture comes in and it joins the cold water line going into the water heater. You'll see an expansion tank, a check valve on the cold water supply, so we don't run any water backwards. And then we have our mixing valve up here on the outlet side of the tank. So again, simple, pretty simple, with a dedicated domestic recirculation line. Now, A.O. Smith is interesting. A.O. Smith is kind of a yes and a no here when it comes to domestic hot water recirculation. They want you to think about what you're doing. And at first I didn't like the way they worded this, but the more I read it, I thought this was actually really smart by A.O. Smith. First off, they start by saying you should consider alternatives to installing a heat pump water heater in conjunction with a residential recirculation loop to prevent the water heater from running continuously due to the lower input of these types of units, potentially causing a no hot water condition. So at first I thought they were they're saying, no, but they actually want you to think. I like the way they worded this. It's actually pretty smart. We do not recommend this heat pump water heater for use in conjunction with recirculation loop systems due to the wide variety of applications and variability in installation and performance of these systems. They realize it's a wild kingdom out there in terms of how domestic hot water recirc has already been installed. All right. They know most of them plug it in, let it run, and I don't care. Worst way to run a domestic hot water recirculation system from an efficiency standpoint. You'll always have hot water, right? But it's the worst way from an efficiency standpoint to run a recirc system. They know that's a lot of them. They know an awful lot of them are on timers, and those timers run whether people are using hot water or not. All of these things are not good for heat pump water heaters. So they're just saying, hey, there's a lot of variability out there. Don't just put this thing in and use whatever's there. If you're going to put this in, think about what you're doing with your domestic hot water recirculation. Okay, so therefore they provide the following guidance. Again, I didn't like this at first because I didn't really understand it, but the more you read it, they were really smart in how they did this. And kudos to us, they're really smart in how they put this thing together. So they go on to say, if your recirculation loop or pump is designed to help provide on demand, there's that word again, on demand, hot water to sink, showers, etc., and does not present a significant continuous heating load, this heat pump water heater can generally be used with on-demand recirculation systems or with those specifically programmed to operate only for short periods of the day when demand is expected. So they give you a little wiggle room for a timer or some kind of an intelligent timer, because that's when demand is expected. But they're really, what they're saying is, if you want fail safe, you want to do this right, it's an on-demand type of recirc system. That's really what they're telling us. And again, very, very well crafted statement. Okay, so energy savings from this heat pump water heater could be significantly impacted depending upon conditions associated with the specific application. The heat energy lost in a recirculation loop can cause your water heater to run excessively. This heat pump water heater may not be able to accommodate demand. So again, they're right there. They're saying you probably should insulate the hot water line and the recirc return line as well. So again, they're very, very intelligent in how they how they worded this. So what does that leave us with? What can we use for domestic hot water recirculation? Well, can we use constant circulation? Well, obviously not. That's a big no from me, dog, and that's a big no from Ream. That's a big no from A.O. Smith, and anybody else who makes domestic hot or heat pump water heaters. They'll just say no. Do not use constant circulation. And in the bigger picture, I would suggest to you all that constant circulation, regardless of what type of water heater you have, is a really bad idea, for the simple reason that hot chlorinated water at high velocities running continuously is the kryptonite for any pipe. PEX, PERT, CPVC, copper. It'll eat that stuff up in no time, and you will have pinhole leaks, guaranteed. All right. And a lot of pipe manufacturers now are saying, hey, they can tell, like especially the PEX people, they can tell if this leak or this pipe failure has been caused by hot chlorinated water running continuously at high velocities. They can tell, and they will deny a warranty claim. And then somebody is going to have an uncomfortable conversation with somebody else, and no one's going to be happy. So constant circulation, simplest, cheapest, and it guarantees hot water 24/7. Get all that. Worst way to run a recirc system from an electrical consumption standpoint, from a water heater abuse standpoint, and from a pipe abuse standpoint. So we do not recommend constant circulation at all. Could you put on a timer? You could put it on a timer. You'd have to be very aggressive with that timer, but timers carry with them kind of there's a lot associated with the timer. First off, who sets up the timer? I don't know. I've heard contractors say, oh, I set it up based on what I think it should be, but then I leave the directions with the homeowner and they can change it, or I just give the homeowner the instructions and let them figure it out. Neither one seems satisfactory to me. The other thing is when there's a power outage, who goes back and resets those things? I don't know if anybody does. Okay, so we got a problem there. Does anybody go back and reprogram or adjust when we go from daylight savings to daylight standard, and then from daylight standard to daylight savings time? I don't know. Nobody knows. I highly doubt anybody has it written into a service contract that they're going to go do that, and I doubt most homeowners even think about doing that. But that's a twice a year thing that kind of messes you up. So constant circulation, I don't think, definitely no with heat pump water heaters, definitely no. Timers are going to be a strong no as well, simply because, again, if I set it to run for 2 hours in the morning, how much during that 2 hour time frame, how much will I be using hot water? I only need to make sure the hot water is at that farthest fixture just once for that first shower in the morning, because subsequent showers, if the water lines are insulated, subsequent showers, the water's going to be there already. So I don't really have to run it continuously, or 15 minutes on, 15 minutes off, or whatever over a 2 hour period with, and especially with the heat pump water, you don't necessarily want to do that. So timers, I will say no, or no in yellow, your choice here. Smart plug, you'd think so, but no, because smart plugs will still work on a 2 hour window. Okay, their operation is 5 minutes on, 10 minutes off, which is cool. 5 minutes on, 10 minutes off is really not a bad way to operate something like this, especially with a heat pump water heater. But you do have that 2 hour window that it's going to do that. So I may not be using hot water, or may not need to, and I might be making that water heater work a little harder than it needs to. So you'd think a smart plug would be a good idea. It's iffy. It's better than a timer, and it's better than constant circulation. I'll give you that for a heat pump water heater, but still not the optimal solution, because again, what are they telling us? They're telling us that the solution is on demand. So on demand is the Taco Genie. Right, the Taco Genie, your on-demand domestic hot water recirculation pump. And with that, we have a winner. Okay, with that one, we have a winner. That's push button operated. It has an internal sensor, temperature sensor, to turn the pump off once the hot water gets there. So the Taco Genie with an on-demand control, it's either a push button, a wired push button, a wireless push button, or motion sensors will turn that pump on. And if you see this guy right here, this little wire going into this brass fitting into the inlet side of the circulator, that is your temperature sensor. That senses a temperature change. Once the hot water gets back to the inlet side of that circulator, the pump will shut off. And it's not a specific temperature. It's simply either a 5 or a 10 degree temperature rise from what it was, a 5 or a 10 degree temperature rise. Okay, so something like this, you'd probably set it to a 5 degree temperature rise just to keep that runtime down to a serious minimum. If this is back at the water heater, you're recirculating that water all the way through. Once it gets back there and it raises 5 degrees, well, we've got plenty of hot water primed in that line. We're in really, really good shape here. So I think that 5 degree temperature rise would be plenty for a heat pump water heater. And again, this is also generally a higher head pump because we want it to work quickly. All right, it's a higher flow, higher head pump. We want it to work quickly. Get that line evacuated as fast as we can, and turn it off quickly, so we really don't abuse the water heater. So the flow rate might be, 3 to 6, it might be 3 gallons a minute. Okay, depending upon the pipe size, and all, it might be 3 gallons a minute, but it's going to shut off quickly, and that's the important part. So we don't abuse that water heater. So push button activation, as we said. Those motion sensors, that little white sensor above the button, that's an optional motion sensor, and you can have push buttons and motion sensors and wireless push buttons all wired in together. Any one of a number of modes to turn this thing on. It's not just one. You can have multiple bathrooms if you need to. All right, and again, that temperature-based shutoff is really, really important. And this can be used in 2 different locations depending upon what you need. Okay, here we show the Genie installed back in the mechanical room at the water heater with a dedicated return line. And as you see from the picture, we've got multiple remote activations. There's motion sensors, there's push buttons, etc. So we have multiple ways of turning this thing on, no matter what bathroom you go into. And then that sensor on the inlet side will turn that circulator off as quickly as possible. So again, higher head pump, higher flow pump. We want to evacuate that hot water line of cold to tepid water as quickly as we can and shut the thing off so it doesn't run very long and we don't abuse the water heater. If you do not have a recirc line, this circulator can be mounted under the sink, provided, of course, there's a vanity. If it's a pedestal lab, I can't help you there. But if there's a vanity where power is accessible, that's always the caveat here. When power is accessible and when it can be done, you can mount that under the sink. And we have it's called the Genie, specific Genie model design for this has an abbreviation at the end. It's -USK for under sink kit. So it comes with all the parts and pieces you need to make that crossover. All right, to make that crossover. People always look at this and go, oh my God, we're going to get hot water in the cold water line. Can't do that. No, you can. Again, remember that sensor. Okay, that heat sensor is going to shut that pump off once the hot water's there. Okay, we get that 5-degree temperature rise. Once we get it, pump's going to shut off, and the pump will not re-engage until that water cools down. That's the other part to this. I could press that button as many times as I want, but if the hot water's there, the pump's not going to engage. Okay, the pump's not going to engage. And the motion sensors also have a 7-minute shut or cutout. So once you activate, say you walk in the bathroom and you activate that sensor, and the pump comes on and then shuts off, you walk back into that bathroom and activate the sensor. The sensor is going to say, yeah, we're good, you're fine. We're not going to turn the pump on again. All righty, that's actually fairly simple. This is a short webinar. This is fairly simple when it comes to heat pump water heaters. The jury is still out in the big picture how most of them feel about it, but based on market leaders, Riemann and A.O. Smith, on demand makes all the sense in the world. Again, and that'd be the Takeo Genie. Now, it's important to note the Takeo Genie is not an ECM circulator. We have our ECM version in development that'll be ready at some point over the next year or so. But here's the thing: for an on-demand circulator that might run ideally our goal is to get it to run less than a minute. If we can get that line evacuated in about a minute, man, that's great. If it's less than a minute, even better. The value of ECM is that it uses less energy, right? Lower electrical consumption per circulator. But if a pump's running less than a minute at a pop, I don't know how much more efficient it's going to need to be. It's just never going to run enough for it to matter. Now, the Department of Energy guidelines that go into effect in May of 2028 mandate that all circulators will be of a certain efficiency standard, meaning they will be ECM. So yes, that Genie's going to transition into ECM. But the point is that up till then, it really doesn't need to be, because ECM is not going to save an appreciable amount of money on a pump that's going to run maybe 1 minute, less than a minute at a whack. I mean, how much more efficient does it need to be for it to make a difference? So in terms of efficiency, yes, there will be an ECM version, but no, in terms of I'm not going to buy this because it's not ECM. It doesn't matter at this point. It doesn't make any difference for this application. Let me know if that makes sense to you. And I want to take a quick pause for the cause. Any questions that you guys have here on the stuff that we've discussed so far? Does this make sense to you? Is it helpful? I want to make sure that we're on the right track and giving you the information that you need. Please let me know if this information is helpful, because I want to jump into sizing next and spend the remainder of our time together on sizing, a sizing tool that we have developed for residential domestic hot water recirculation. So let me know if this has been useful. Does it cover new ground? Is it stuff that you can use? That's maybe the most important to me. We got a yes from John Booton. Very helpful from Will. Very good. Makes sense from Jose. Excellent. Excellent. Have you seen the swing tank method for commercial? I'm going to say a no on that one, Scott. I have not. That would be kind of an interesting thing to take a look at. It's swing tank. I'm wondering if that means buffer tank, Scott. I mean, the heat pump water heater makes the hot water, and we got a second tank that stores hot water. Is that where you're going with this? If not, let me know. I'd be interested in hearing what that means. But what I'd like to do now is go to our website, do a quick link, and bring that over to our website. So I'm going to pop this over here, and I'm going to hope you guys can see this. Can you see this? Yes, you can. All right. This is our Takeo website, And what I'm going to do here is I'm going to go to Selection Tools. Click on this thing right here, Selection Tools. If you click on Selection Tools, and all this is available to you, it's free. You'll see you'll see three different options here. I'm going to go to DHWR Size Right Circulator Sizing Tool. That's how we have an online tool to help you size a domestic hot water recirc line for residential applications. I want to stress that, residential applications. We do have a question before I jump into that. We do have a question here from Jonathan. Is there a sensor that can be added to an existing system that would allow for on-demand control? I wouldn't say it's a sensor so much. It's an activation kit, basically. You've got to find a way to be able to manually activate a circulator. All right. So anything, push button that completes a circuit to whatever circulator you have, that would be that would be half of the equation. Okay, that's half of the equation, Jonathan. You have to have that on-demand manual. I have to push a button. I have to physically do something to turn that pump on, and then there has to be an automatic way to shut that off. Okay, once the flow is there, and then something built in that's going to prevent you from hitting the button again. So can you do a homemade version of that? I think to a degree you could. The trick is I got to have a lockout, so I can't just hit it again, hit it again, hit it again, because if somebody can do something, they probably will. It's that lockout that's kind of the key here, that we don't run it excessively, especially with motion sensors and things like that. So an aquastat would probably do a similar thing, although that's not on a temperature rise. That's simply a specific temperature, better than nothing. A push button, you can manually rig one up, but it's that lockout that's the important part, so we don't accidentally or unnecessarily run that pump. All righty. Very good, very good. Takeo Genie, not recommended for commercial applications with heat pump water. If it's big enough, again, we have three sizes. The key here, Tim, good question. The key here is it big enough for the application? That's going to be the key. And we have three specific sizes: 006, 008, 0011. The 0011 is big enough, it might be to do the job you want. And that's a possibility. Okay, that's a possibility. We just don't want it to run too long. Alrighty, very good, very good. So let's go. I'm going to click on system, the DHW system sizer, and just kind of walk you through what we're going to do here. We start with kind of a just all disclaimers up on top. Okay, so we can keep that up there. We can hide it. I'm going to hide it for right now. Then we just get into it. It's just a form. You fill it out, and it'll help you spit something out. So is there an existing, or will there be a DHW recirculation line installed? We're going to click on yes. Water heater type. I'm going to pick tank. It does not at this point specify anything for a heat pump water heater. That's going to be up to you to make the decision. Piping layout, trunk and branch with recirculation or full-size loop. I'm going to pick trunk and branch with recirculation. If you're not sure, you can view a sample piping layout here. And in this case, it'll pop up a PDF, and it just gives you what it looks like. So again, farthest fixture, we have this yellow line coming back as the recirc line for either tank or tankless. So it'll give you a drawing if you're not sure what you're looking at. All right. Supply pipe material, return pipe material. Again, you have a choice of PEX PERT, CPVC, copper L, copper M for your supply. We're gonna go with copper M, and then return. Again, it could be that a separate material was installed as a return line, so you can pick a different return material. We're gonna stick with copper M. Piping calculations. I'm gonna click on this little thing called Show Details because it gives you a lot of interesting information here. So we want to start laying, all we want to do is tell it pipe size and length. That's all we're after, pipe size and length of the run to that farthest fixture. All right. So we're going to start with, again, let's say 1 inch. Okay. And again, it only goes up to 1 inch. This is for general residential. Okay. It's for general residential. You need bigger pipe. This calculation package isn't going to work for you. It's the way it is. So 1 inch pipe, and how much? Let's say it's 20 feet of 1 inch. I hit my tab button, and you'll see it's going to tell me how many gallons I have per foot. All right, how many total gallons in that 20 feet of pipe. Pressure drop hasn't been calculated yet because I don't have a loop yet. Okay, now We go next to 3/4 inch type M, and let's say there's 70 feet of 3/4 inch M. We hit tab, and again, we get an idea of how much pipe water there is per foot and how many gallons are in that total 70-foot run. And then we finish it up going to the fixture with 1/2 inch, and let's say that's 30 feet to that farthest fixture. And it's telling me how I've got a little less than 4/10 of a gallon in that 30 feet of pipe. Now that's the supply. Now we size the domestic hot water return line. So that size of the pipe, let's call it 1/2 inch. And let's say it's not 100, let's say it's 120 feet. Now I'm going to hit tab, and you're going to see the pressure drop columns populate. Okay, here we go. So right now it's telling me my pressure drop on the supply line is 1.96 feet ahead. All right. I've got a little over 3 gallons of water in that supply line, and I've got and just under 2 feet ahead on the supply side. The return line, I've got about a little over 1.5 gallons of water, but that pressure drop through that 1/2 inch pipe is a little over 5 feet ahead. All right. Now that gives us, now we've got something to work with. We go down here and we get a summary. 1.6 gallons per minute. That seems like an arbitrary number to land on, and I'll tell you why we land on that in a minute. It's kind of an arbitrary number, and total feet ahead of 10.11 feet. Well, 1.96 and 5.26 is far lower than 10.1. Where did 10.1 come from? Well, we look over to the right, we see I'm including 40%, a 40% add-on in length for valves and fittings. Now that might be high, that might be low. That's going to be job dependent, okay? And then it's also asking me, is there a mixing valve present? So yeah, I'm going to say, that's kind of excessive. I'm going to go to 25%, but I am going to add a mixing valve. Okay, and the mixing valve at this case is going to add, and I can put in I have the ability to put in the number here for the actual mixing valve. It defaults to 1.8 feet ahead, but you would put in whatever would be applicable for the mixing valve you use. So basically what I've done I've added the mixing valve, I've reduced the valve and fitting percentage. I'm still at about the same. It's about 1.6 gallons a minute at 10 feet ahead. Now, why 1.6 gallons a minute? That is an industry guideline. The pipe manufacturing people, the Copper Development Institute, et cetera, have put limitations on flow rates in recirc lines, just the recirc portion of that line, to prevent to keep velocities under control. We want velocities around 2 feet per second in a recirc line, to prevent pinhole leaks and internal erosion and things like that. So 1.6 is a maximum. It's not a target, it's a maximum, okay, to prevent that corrosion in any kind of a timer-based system, constant circulation system, or even a smart plug. Now, we're not doing that now, so that's interesting. We're not doing that. So you have to understand what's going on here. Now, circulator efficiency types, I'm going to go standard efficiency only, just because I want to get the genie here. Connection types, we're going to go all, and then what I'm going to do here is hit search. Okay, right now it's giving me a 0012 stainless steel is my particular solution. In reality, what I'm going to be using is probably in this application would be the 0011 genie. Okay, but this is going to give you some kind of a connection here. And if we went to Union, that might change there'd be no suitable product on, but we know the genie is going to cover that. Okay, so we go back to all, and we do our search. It's selecting the 0012, but really what we're going to use is the 0011, and we'll take a look at this. If we click on this report and go to this pump curve chart, it's going to tell us something here. All right, here's what it's telling us. 1.6 GPM is right here, and it's picking the 0012, which is this guy right here. But if we take a look at number 3, which is the 0011, okay, the 0011, that might be a better choice. In fact, you might make a case that a 008 is going to be a better choice. And I would, if you, the 008 curve is not on here, but I would suggest that a 008 might be a better choice. Because if I had the 00, if I put the 0011 Genie, I'd be operating up in here somewhere, which again, we're cognizant of that 6 gallons per minute max. We really want to be between 3 and 6. We'd like to be up in here. So if we put that 0011, yeah, we'd probably be right up in here at about 4 gallons a minute. If we're operating at 4 gallons a minute, okay, they said the target's 3, do not exceed 6. 4 gallons a minute is within the acceptable range. Let me show you something. If we're operating at 4 gallons a minute, okay, let's go back up here. If we're operating at 4 gallons a minute and the amount of water in my supply line is a little over 3, that pump's going to run for just about 1 minute. All right, probably a little less than 1 minute, 45 seconds maybe. We're going to evacuate that line quickly, all right, in less than a minute, and then it's going to shut off. So that's kind of, well, it's going to run for a minute to get the hot water to that farthest fixture. We got another 1.5 gallons. So together, okay, we'll probably run, if the circulator is on the return line in the mechanical room, you're probably going to run for a little bit over a minute at that flow rate, at that, with that circulator. Let me know if that makes sense. Okay, if what I just said makes sense. Based on the amount of water in that entire loop, 3.9 plus 1.58, we're running at about 4 gallons a minute. It's going to take a little bit more than a minute for that circulator to deliver the hot water and shut itself off, which if we're looking to have as little impact as possible on that water heater, I think that's the best way to go. So let me know if that makes sense to you and if this is a usable item. It's not necessarily at this point, because we're working on updating this with heat pump water heaters. It's not going to necessarily give you that on-demand type of product, but it will help you size it and it will help you make some decisions. Because again, as long as you know how to use it and what it all means. So in this case, yeah, if we can run that pump for a little bit more than a minute, I think we're in pretty good shape. Okay. Jose asks, but which value has to be used? Give me what value are you? Give me a specific on that one, Jose. What specific value are you referring to? And again, if I was a little unclear, let me know. I want to make sure I answer that question, but I'm not sure. Gallons per run. Well, gallons per run. Okay. You want to good question. Okay, now I got you. If the circulator is in the mechanical room on the return side, which is where it should be, I add them both together, 3.19 and 1.58. How long is it going to take for that circulator to shut off? Okay, it'll take less than a minute for the hot water to get to the farthest fixture, right? It's going to, maybe this is where it got unclear. It'll take less than a minute. If I'm running at 4 gallons a minute, it'll take less than a minute to get the hot water to that farthest fixture. It's going to take a little bit more than a minute for the hot water to get back to that inlet side of the circulator for the circulator to shut off. All right, that's a better way of saying it. Thank you for asking for the clarification. I got to clarify. I appreciate that, Jose. I appreciate it, man. So again, that's kind of how that recirc pump is going to work. That is how you can interpret this data and apply it to the Taco Genie specifically. And this is going to be our method of delivering on-demand service for a heat pump or hybrid water heater. Timer, really bad idea. Constant circulation, an even worse idea. Smart plug, it remains under consideration. It's a 5-minute on, 10-minute off cycle, but it's still gonna run for that 2-hour period. And that's where I could see some water heater manufacturers not really jumping on board with that. And I don't blame them. This is their equipment they're talking about. We're talking about here, not ours. 5 minutes on, okay, we'll be fine here in terms of delivering hot water. That's going to work and work just fine. And once it shuts off, we're okay. But it's doing it doing that 5 minutes every 15 minutes for a 2-hour period. That's where I think a smart plug might be problematic with a heat pump water heater. That plus the fact that it can be put into a pulse mode simply by pressing a switch on the bottom. You can put it into a pulse mode where it does 5 on, 10 off, 24/7, and that we absolutely don't want with a heat pump water heater. So again, I don't necessarily recommend. Smart Plug's a great product, but I don't think it's going to be the right solution for a heat pump water heater. Again, that on demand really, again, you saw how many times both Ream and A.O. Smith use the term on demand, on demand, on demand. So I think that's really kind of where we want to go with this. If we do, I do want to share something with you. I'm going to remove this and I'm going to change. What if we were to change the return line from 1/2 inch to 3/4? What does that do? Well, there's a little bit more water involved, but you'll notice the head goes, well, it gives us up to 3.2 gallons a minute. As a max, we could do that, but now we're looking at 20 feet ahead. And I said, no, I don't think we want to do 20 feet ahead. But that's just telling us we can do 3.2 gallons a minute. If we change that to say 2 gallons a minute as a flow, or 2 gallons a minute as a maximum flow rate for design, we're going to get that headway down. Now we're looking at the 008, and now, okay, we're still going to get that hot water out to that furthest fixture, within a couple minutes now, 2 gallons a minute. It's going to be about 1.5 minutes, but now it's going to have to run, that's 6, it's going to have to run 3 minutes, which a little longer. So going with a larger pipe in this case is more volume. It gives us some opportunities for a smaller pump, but it runs longer. If we, it depends if we want to go that route. So all discussions, all things to think about. But again, I think with a 1/2 inch return line with a 0011, I think we've got a pretty good solution there. Absolutely pretty good solution. All right, got another question here. Let's see, can we review 2 things? Let me get my glasses on so I can see that. Seems that heat pump manufacturers require 3 to 6 gallons a minute, but the TACO curve you were looking at index at 1.6 gallons per minute. Well, again, 1.6, this is where we have to understand what this thing tells us. 1.6 gallons per minute is the limit placed on flow through a 1/2 inch recirc line, placed on that by the Copper Development Association to protect the copper pipes, primarily in instances where you are going to have continuous or timed circulation. All right, they are they're recommending 3 to 6 gallons a minute. That's their general guidelines for 3 to 6 gallons a minute. If, as we could see in our example, if we were running 1.6 gallons per minute, usually three isn't a requirement, it's a maximum. Okay, it's a guideline, if you will, for the heat pump water heaters. If we ran it at the guideline showed 1.6 gallons a minute, but that was the limitation for 1/2 inch copper pipe placed on that by the Copper Development Association to keep velocities in continuous circulation systems under control so we don't erode the pipe. That's where the 1.6 came from. Okay, that's where the 1.6 came from. When we and that's why it gave us the 0012. If we looked at the 0013 pump curve and the 0011 pump curve and a 0011 Genie, we saw that flow rate, if we followed the pump curve up, would actually be 4 gallons a minute. Now, at a rate of 4 gallons a minute, that pump was going to run about 1.5 minutes total before we got hot water back to the inlet side of the circulator. So I'm hoping that clarifies that. That's kind of where we're going. Again, that heat pump manufacturer 3 to 6 gallons a minute. It's not a requirement. It's a limitation. Okay, they give you 3 with a maximum of 6. They're not saying it's got to be 3. This is right around 3 is good. If we do right around 4 with which is where it would be if we put that 0011 on there, it would be right around 4. We're within their flow rate guidelines, which works just fine for the heat pump water heater. Also understand it's only going to run 1.5 minutes. And I think the time the time element is just as important, if not more important, than the flow rate. Okay, and let's see, what about 10 foot ahead? 10 foot ahead in TACO calc, it didn't seem to use that in the pump selection. It actually, when it selected the 0012, that was the standard efficiency pump whose performance curve was just above what the original requirements were. Okay. What we did was I said, well, the 0012 is great, but we don't, when we're talking about the Genie, we have Genie in the 006, 008, and 0011. So we chose the 0011. And if you followed the system curve up to where it intersects the pump curve on a 0011, we'd be looking at about 4 gallons a minute. Let me know if that makes sense to you, Jonathan. That was kind of a convoluted way of explaining it, but that's kind of where we're at. That 3 to 6, it's not a requirement. It's kind of a maximum. 3 gallons a minute is okay. You know, don't go more than 6. But if we can do it with 2, we could do it with 2, right? You know, just understand the important part is taking a look at the gallons per run, how much water's in that system, and how quickly can we get that pump to shut off. Okay, that I think is the key. Without exceeding 6 gallons a minute, obviously. Here we were at 4, we're good. Okay, we're good. All right, good, excellent, great questions, guys. Great questions. I really appreciate it. Any more? Keep them coming because we got about 5 minutes left in our time, and I have given you all the stuff here. So I want to use a heat pump water heater in conjunction with a 50-gallon electric. Any pump recommendations? Going to need to know a little bit more, Mark, on how you plan to do that. If the heat pump water heater is going to feed the 50-gallon electric, and then you recirc through the 50-gallon electric, you have a full palette open to you of options for domestic hot water recirculation. All right, you're going to need a pump you're going to need a circulator that will you want to feed the 50-gallon, right? So the heat pump water is going to feed the 50-gallon. For domestic hot water recirculation out in the system, you got the full palette open to you, man. You can do whatever you want. You can do on demand. You can do depending upon the flow and head that you need out there, a 006 E3 with a smart plug, maybe the best solution out there. Obviously, you're going to have a recirc line if that 006 E3 fits the requirements of your system. I'm going to guess, Mark, this is a residential application, and or even a light commercial. Again, it's a flow and head thing there at that point. But if you're recircing through the 50-gallon electric, you can do anything you want. All right. I don't recommend obviously constant circulation because you're going to run into all those other problems we discussed. I'm not a big fan of timers for the reasons we discussed. I think we're looking at a smart plug there would be the best solution for you. Now, just to feed the circulation system between the heat pump water heater and the 50-gallon tank. Again, now that's going to have to be, that's just going to have to be, I think, it's just there's no specific requirement there. It's just that the aquastat in that water heater is going to, you're going to have aquastat or something in that water heater that's going to enable the circulator to require that heat pump water heater to feed that. If that's what we're looking at. But on the domestic hot water recirc side, the world is your oyster, my friend. You can do the full palette of offerings is available to you there because you're going to be recirculating through the electric, not through the heat pump water heater. So let me know if that answered your question. Cool. All right, folks. Anything else out there? Again, please keep them coming. I'll stay on as long as you want to answer whatever questions you have about domestic hot water recirculation, controls, any hydronics questions. Hey, you got me, man. There's 88 of you there. You got me for the next. You got me for. It's a captive audience. So whatever questions we can answer for you, happy to do so. And you're keeping me from going out and walking the dog in 100-degree heat. So anything I could do to stay in the air conditioning, I'd appreciate. Jose, thank you very much. All right, appreciate it. Thank you, Jonathan. I'm glad you enjoyed it. We try to do our best and we try to keep these things interesting and conversational. I don't know about you guys. I've been to a lot of webinars where they're like exceedingly boring, and I try very hard not to be boring. That's maybe my biggest fear in life. So hopefully this wasn't too boring for you. We had a good time here, and I got to fly solo without my peeps, without Jason and Dave. And Dave is one of these guys. He'll always say to me, he says, "You sure you can do this alone?" I said, "Dave, I've been doing this. I did this alone for a long time before you joined us, so I think I can handle it." All righty, folks. Terrific. Well, one last call for questions, and then we'll say so long to everybody. But again, do appreciate the gift of your time. It's always fun to spend this time with you and be able to help out if any way we can. Okay. John says doing a lot of heat pump water heaters and now with booster tanks, so very relevant. Oh, great, excellent, Jonathan. Like I said, we're going to be working more closely with some heat pump water heater manufacturers just to find out what they need in terms of product, in terms of control strategies and things like that. So we can include water conservation along with the significant energy conservation that heat pump water heaters provide. So we want to make sure we get both bases covered because water conservation really is just as important. So great, subs need lots of training. Hey, and we're here to provide that, man. That's what we do. Taco, just so you guys know, Taco is the only company I know of in the HVAC industry. We have 6 full-time trainers on staff. 6 people who do nothing but train. All right. A lot of companies have, engineering department or product management. They'll dabble in training. They'll do this, they'll do that. We have 6 people who do nothing but train. 3 of us do residential training and 3 do commercial training. So it's a commitment that our owner made many years ago to basically to help as best we can, help everybody be as successful as they care to be, and understand fully not just our products, but applications and challenges and big picture stuff. So there we go. All righty, folks. Hey, thank you so much. Looks like the questions have dried up. It is now 1 o'clock. So I'm going to say thanks for being with us. We do appreciate the gift of your time. Have yourselves a fantastic rest of the week. And we'll see you, I believe next Tuesday, our commercial team is going to be taking over Takeo Tuesday. So that should be all kinds of fun. Actually, no, I don't think we're going to have one next week because it is 4th of July week. So it'll be the week after. So we will see you all then. Have a wonderful, wonderful week. A happy 4th of July. And try to stay cool out there, people. Try to stay cool, especially you 100-degree types down in Philadelphia. All right. Take care, everybody.